Hi guys, welcome back. Happy New Year. Happy 2021 as a car races down my street. Welcome back guys. We anticipated, I guess, for last week as the recording of this video that we'd be back in class starting next week, which is not happening now for at least another 2 weeks. We're looking to MLK holiday post return. We'll see how that happens. So back to more virtual learning, which we all just love so much. Actually, some of you are doing pretty good this way, and some of you I can tell would probably be best benefiting if I got to see you in person. But that's neither here nor there. My dogs are here. Welcome you guys back also. So let's get right into it, shall we? Today's topic is going to be on simplifying polynomial expressions. Simplifying just basically means taking a big long expression and making it shorter. Polynomial means that you have an expression that's made up of different multiple pieces, or terms in this case. And an expression is any math problem that doesn't have an equal sign. It's not equal to something. So all we're doing is taking big long expressions and making them shorter. And there's a couple of basic rules to do that. For these notes today and for your grade, what you're going to do is you're going to go ahead and digitally show me the process that I'm going to explain to you right now, which is in order to combine or simplify polynomial expressions, you need to make sure that all your terms are lined up, and they have to be like terms. A term, for example, are all the pieces of your expression. Example, 4x squared, positive 5xy, negative 3x, 6x squared, positive 8xy, positive 3x. In this case, this total problem has 6 terms in it. Terms are also defined by how many that there are of those things. So for example, we have 4x squares plus 5xy's and negative 3x's are attached to it. Notice how I said that, because when you're adding, subtracting polynomial expressions, all the pieces, the signs that go in front of the numbers are also included in the way you're going to add or subtract and multiply and divide later on. Here we have positive 6x squares plus 8xy's plus a 3x being attached at the end there. You can only combine terms that have the similar endings. So for example, x squares can be combined with other x squares, xy's with other xy's, and the letter x with the other letter x. Neither shall the others mingle together. And what you get at the very end is your simplified answer. It's pretty easy. Now what we're going to do according to our notes is we're going to go ahead and stack these, which means we're going to go like elementary school style where you put the one on top of the other and you kind of add them up going vertically. It's a really easy and effective way, actually, believe it or not, to manage your work, especially when we get to the negative stuff. Because like I've told you many times before, most of the errors aren't necessarily conceptual, meaning that you don't understand the things. It's when you're rushing and you're overconfident and you're adding, subtracting, multiplying, and dividing negatives. It's always negative numbers. Just trust me. I've told you guys so many times, and whatever, it's a thing. So we're going to stack this. To do it digitally, it's really easy. I'm going to go right before the plus sign, press enter. It thinks I want to make another list, but just backspace that. And then I'm going to go ahead and backspace again, and then space it out a little more so they're more or less lined up. Now, what we have here is I need to check to make sure that in each column, I have the same numbers, the same kinds of things, the same terms, in other words. So here I have 4x squares being added to 6x squares. That works. Xy's with xy's, x and x. So those all work. So all I need to do now is go ahead and just add them up, in this case vertically, and get the final answer. So 4x squares plus 6x squares gives you 10x squares. And what I'm actually going to do is cheat a little bit, because I don't want to go through the whole process of writing the variable and having to do the exponent and all that stuff. I'm going to go ahead and just copy paste, and I'm going to change the number. The number in front of these terms actually has a specific name in mathematics, and that's called the coefficient. I almost literally forgot it right now. That's why I kind of hesitated. So in this case, the coefficient is going to be 10x squared, because 4x squares plus 10x squares, excuse me, 4x squares plus 6x squares gives you 10x squares. Now moving on, and it looks like I'm going to have to play with this thing anyways with the exponent. So let me go ahead and just get rid of that exponent piece. Let's see. I think it's going to be getting rid of the superscript. There we go. Full-size cursor. Now plus side, let's see. 5xy's plus 8xy's. Positive 5 plus positive 8 gives me a positive 13xy in this case. Negative 3x plus positive 3x. Negative 3 plus positive 3. A negative number plus its opposite self will always give you 0. So I have 0 x's. If you really want to get like mathematical and nerdy, you could say plus 0x. But let's be honest, when we have 0 of something, we don't label it anyways, because otherwise you have to label everything you don't have. So we'll leave it just like that. And I'll go ahead and highlight my answer, which you'll do similarly when you do your example. So let's go ahead and highlight this. I'll pick a nice, lovely shade there of yellow, but I don't care what color you choose. All right, moving on over here, number 2. Now we're going to deal with subtraction. So I need to make sure that I'm going to stack them first. And then, whoops, I did not mean to do that. Actually, I kind of did. I don't know why it gave me attitude. Hold on. There we go. All right, so I have to make sure that my terms are all alike. So m squares, m, just number. By the way, when you have a number attached at the end, which you will frequently see, that number that has no letter, no variables attached to it or anything, that's called a constant. It's just that number, whatever it is, okay? So remember that little phrase. All right, so let's go ahead now and let's combine everything. 11m squares minus 5m squares leaves you with 6m squares. Yes, I know I didn't want to have to deal with it, but for those of you who may not know how, you go ahead and just go up here. You highlight the 2, go to text, superscript, and that gives you the thing that looks like an exponent. All right. Now, here's where you're going to want to definitely consult your calculator. Use Desmos, your phone calculator, I don't care. But please just do not rely on your memory for doing the addition and subtraction with negative numbers, because that's always where issues come up. If you're confident that you know what you're doing, then go ahead and just do it in your head or whatever, and then check it. Just check your work. That way you don't make these basic errors, these bonehead mistakes, which are so easily fixed. So 2m's minus negative 6m's. So there's at least 4 popular answers students would always get, and only one of them would be correct. You either get plus or minus, positive or negative 8m's, or positive or negative 4m's. And it's because they know to either add or subtract, they're just not sure which to do, and they always get crazy sign mixed up. So just do it right now. 2m's minus a negative 6m. So if you're starting at 2 on a number line and you go subtract, that means you're going to go left generally. But the negative in front of the 6, and remember this negative sign does go, the subtraction sign gets treated like a negative in front of the 6. It's actually going to flip my direction, which means I'm going to end up adding. 2m's plus 6m's gives me 8m's. When you're subtracting a negative, you're really just adding a positive. That's the effect it has. If you don't believe me, check on your calculator. All right, going on, last piece. Negative 11 minus positive 17. So if I'm at negative 11 on a number line, picture that in your head. You're on your negative 11 steps to the left of 0. Minus means you're going to go more negative 17 whole steps. So it's going to get even more in the negative direction at negative 28. And there is your final answer there for number 2, which we will now denote by highlighting. Oops, I don't want to highlight everything on the screen, just my answer. All right, let's go on now. Ignore this floating positive sign here in the middle of the screen. It does just ended up there. Is it something that's editable? There we go, just take it right off. Don't know why that ended up there. All right, let's go ahead and stack and add once again. Bless you, dog. All right, now make sure first before we add it or combine anything, because combining could be also subtracting. Let's go ahead and, oh, I see what happened now. When I did that, it added an extra cell here for some reason. I think that's why she had that plus sign there. I didn't make these notes, Miss Corral did, so I blame her for everything. Oops. Let me just go ahead and return everything. When you make a mistake, undo is your friend. Well, I have room. Yeah, I'm still good there. Whatever, I'll leave it at that. Who cares? All right, so back to where we were. Everything's lined up. Just combine 2x squared plus a singular, or 1x squared if you really need to see it, gives us 3x squares. I'll go back and edit that in just a second. Positive 3x's plus negative 5x's. That means I'm going to subtract. Positive 3 plus negative 5 means 3 minus 5, or in other words, negative 2x's. And then positive 2 plus negative 5, just like the last one. 2 plus a negative 5 means 2 minus 5. And 2 minus 5 is going to be negative 3. I need to make sure to make this an exponent. So I'll go ahead and do that really quick, make it a superscript. I never learned how to use those shortcuts on here. Kudos to any of you guys who know how to use the keystroke shortcuts to make exponents. That is something that could really actually help you, at least as far as being faster. And there's my answer. All right, now number 4, 5, and 6. I think I'm going to leave, actually, I'll keep going number 4 with you. I'll probably leave you just with maybe, oh, there's more problems there. Never mind. I was running out of examples here. Same thing, stack and combine. Let's make sure all our terms are lined up. X squares, x, constants, yes. All right, so I can now get my answer. At this point, if you want to go ahead and pause it and get your answer and then compare it with mine as I do it, even better. Otherwise, I guess keep watching and make sure you ask questions in real time if you're not sure what I'm doing. 2x squares minus a singular or 1x squared, which means I'd be left with just a singular x squared. I'll go back and edit that exponent later. And I do not want that capitalized. All right. 3x's minus negative 5x's. Remember, I told you minus a negative means you're adding. So 3 plus 5x's gives me positive 8x's. Whoops, put a 6 there. All right, and then positive 2 minus negative 5, like I said before. Minus a negative means you're really adding. So 2 minus negative 5 means 2 plus 5, which gives me a positive 7 or plus 7. Let me get my exponent up in there. Let's see. It was under format, text, superscript. I'll highlight it another color. I don't care if you want to be consistent in your color or if you want to vary. It's your call. It's a little dark, I think, but I can still see it. Can I just get rid of these two cells right here? I'm wondering if it'll let me, or at least, I'm not sure why anything's even in there. It's interesting. I can take out either one. There we go. If just backspacing a lot kind of takes out whatever space they were taking up. All right, now number 5, the only one that's slightly different, and now we're going to have to apply distributive property, which means we're going to have to multiply the outside stuff times the inside stuff, and then we can combine our like terms. So let's go ahead and rewrite both of these. I hate when it does that. I can actually move this a little space down too, just to give me a little more room. All right, so here we go. I'll go a little to the left. 2 times 3x's gives me 6x's. 2 times a positive 10 inside the parentheses gives me a positive 20. Continuing on, positive 5 times x gives me a positive 5x. Positive 5 times negative 4 gives me a negative 20. Now I combine like terms. I can only combine x's with x's and constants with constants. So I have 6x's, positive 6x's, plus 5x's gives me a total of 11x's. Then I have positive 20 minus 20 cancels out, so I'm left with just 11x as my sole answer. So what looked kind of complicated ended up being pretty easy. All right, so let's go ahead and apply that again over here for number 6. Actually, I'm going to leave number 6, 7, and 8 for you guys to do. So go ahead and get those done either on paper. Actually, don't do them digitally like I did. There's absolutely no reason why you can't. So get me 6, 7, and 8 done as part of your notes completion grade. When you're done, attached with this assignment is the Google form for simplifying expressions. Ta-da! I'm going to edit these class periods out. But nonetheless, here's what it looks like. You're going to have some problems to work out. It's all multiple choice. All right, so go ahead and get on that as soon as you finish the notes. Get it all turned into me hopefully by tomorrow, so that way you don't have to waste any time this weekend doing any makeup work as we start our new 9 weeks. As always, if you have any questions, feel free to ask me. Otherwise, best of luck and have a great day. There we go. Bye, guys.